Welcome. It's Thursday, 1 p.m. Brazil time. It's seminar in computer engineering time. It's game time. It's cloud gaming and extended reality time with a fellow postdoc researcher, Alireza Shirmarz. He's a researcher at the Federal University of São Carlos. He works now for over 1 year, has been working on this topic in the SMARTNESS Engineering and Research Center, funded by FAPESP and Ericsson. It's a center that I'm very proud of since I'm the director. And it's a pleasure of having Alireza not only in the center, but today here in this seminar to share more about these network traffic patterns around these popular applications, cloud gaming, extended reality. As usual, Alireza, I don't spend time. Folks can read, see your biography, find more about your publications in Google Scholar. I know you will point to some of them today. And with that, I hand over to you, and I'm looking forward to talk in around 40 minutes. I will be selecting some smart questions from our students. Everyone over YouTube, feel free also to share over the chat your questions. And that's all for right now. Ali, can you share your screen, please?
Could you see that? Yes.
Yeah, it's coming. Thanks.
Thank you, Professor Christian, for giving me this opportunity to present today about the cloud gaming and extended reality. I am Alireza Shirmarz, the postdoc researcher in UFSCar, and I try to present about the cloud gaming and extended reality, and try to answer this question why we need to focus on the cloud gaming and why it is important, and what is the challenge that we have in the research area in this area and in this topic, and what is important for the network management, why it is important for the network management. I started with this section that in the network management system, we have different types of the protocol, different devices, different administrations across all over the world, and something like this. And so we need to have the network management system to be able to manage the system, because we want to provide some quality for users and the network for the users. So this complexity push us to be more smarter than before, because we have many devices, users, and it is going to be more scalable than before. One of the applications that is demanding now is cloud gaming. And one question for the network management system is this: how we can, for example, identify the cloud gaming traffic in the network, and how we can provide the quality of service for this type of application. It is the question that we have in the network management system. The first and simple answer is this: that we can work on the IP and the port number, because every client-server model traffic has one server that it has IP and the port number that presenting the application in the server. But when we dive in this type of the application, we see that yes, the IP and the port are changing frequently, and we cannot count on the port number because it is changing always. And for the IP, only we can keep the octet one of the IP in each platform. So it is difficult for the network management system to do this, to track the changing IP and the port number frequently in the application side, in the server side. So the other challenges that we have in the network management system is this, that most of the payload is encrypted. So we cannot use the payload to identify the application type and try to prioritize this type of application to the other application. So we need to use something like machine learning to identify this. But in this way, we have some challenges that we are trying to do this, and we have some research that they did that today I try to talk about this more. The other thing is this, that in the network management, we want to keep the users satisfied. So the first thing that they think is this, that they need to keep the quality of experience prioritized. But how we can do this? The quality of service has some KPI that we can use to tune and configure the network to provide some level of the service for the customer. It is what we are doing now in the network management system. But in the quality of experience, it is different. And we have different types of the evaluation, and we need to be more in detail about this. The other thing is the cloud gaming drivers. What is trying to push this type of the application to improve? For example, the devices that now we have some devices like the VR glasses that they have pass-through capability. They push us to have different level of the quality in the images and videos that we receive, and the controllers that we can use, different types of the controllers that we can use. They are pushing the cloud gaming system to have different types of the quality of experience. And the other thing is this, that we need to have the adaptive resource allocation in the network. I try to introduce the first definition that we have. Then I will try to talk about the drivers that caused us to be more in detail about the cloud gaming application. As I mentioned, the quality of service has some measures like latency, jitters, and packet loss that we can control the network using some techniques like shaping, resource reservation, and prioritization mechanism. And we can have the SLA that now it is so common. But in the quality of experience, we need to be in touch with the human that using that application to see how it is felt when the guy is using that application. The challenges that network management is facing is this, that all of us using different user equipment, and end system. For example, we use laptop, cell phone, and the other devices. And we install different softwares on this device, and we use this device while we are using the connection to the internet. And when we are using this type of the application and installing our device, we are generating traffic. And when we are more than one people and we are using more applications installed in our end system, we are generating traffic. And in the network device, we don't have any identification communication between different applications. So we receive only packets, but the user is using the application, but in the network side, we only receive the packets. So we need to extract the application from this type of the statistical information and some headers in the packet to know, yes, it is, for example, this packet is belonging to this type of application. The other thing that it is important in the quality of service and quality of experience provisioning is this, that the network condition is changing and varying during the time. So we need to have the feedback from the network situation and condition. In some location and in some interface of the network device and network location, we have a bottleneck. Why? Because the resource is less than the demanding traffic. So we will have the bottleneck, and in this bottleneck, it is more likely to experience the congestion. So we need to think about this and avoid this type of the congestion, control the congestion. And if it happens, we need to reduce the time that congestion is running. The other thing is this, that when we are running the application, we are dealing with the end-to-end resource, and we need to have the end-to-end resource control. But most of the time it is not possible because we are using different network under different administration until we can use that application. So it makes the network management critical because they need to have the real-time monitoring and adaptation during all the time that network is running. The other thing that is important to have the better quality of experience for one application is this, that we need to identify the application with the traffic statistics and the headers. And the other thing is this, that we can do routing and path selection during the network devices. And or we can use slicing in the 5G, for example, or in the edge computing. We can use, for example, slicing in the 5G to, for example, for the cloud gaming, we can use the URLC, that it is one slice that it is for the low latency, or we can use the eMBB slice, or we can use the edge computing to reduce the propagation delay. The other thing is this, that we need to have the adaptive algorithm for the quality of experience, and we need to receive the feedback during the time that we want to use this technique in the network. Okay, I want to talk about something that I know that it is nostalgia, and we played in the past, all of us, one of the games in video games. In the past, when we were talking about the video game, we were talking about the consoles, and this console including the hardware operating system and some application installed, and the game installed in this hardware, and we use this type of the application. It was locally running, and since 1977 until 2010, we had this type of the video gaming. But OnLive tries to introduce the cloud gaming for the first time, and they started to use the cloud technology in the in the video games, and Gaikai, it is the second one. And after this, we see that the famous and common platforms are using this type of the technology, cloud gaming, instead of using the spending and investing on the console. And we see that after the VR glasses, we see that this type of the device is pushing the cloud gaming technology to have the other type and the other level of the quality of experience. So it is technology driving now that we need to pay attention about this. Let's too short. I mentioned that what happens in the video games during the time. It is, as I said, that we had the console. This console was coupled, the hardware and software. They had the specific operating system, and when we bought the console, we couldn't, for example, play with the other platforms, and we had some limitation like this. But its performance was good because of the compatibility between the software and hardware. But we had the high cost benefit because we needed to buy this type of the console, and we only could play with one type of the platforms and games. It was difficult to upgrade the hardware and software in this type of the console. And multiplayer scalability was challenging. And we needed to, for example, play in the local situation. We needed to invite our friends to have playing together, but in an indoor place, for example. But in the other steps, we see that the computer-based video games appeared and it was introduced. Then we have the general purpose operating system like Windows, Linux that we use. And then we can install different platforms and we can have different game application, and we could run this type of the application. It improves the flexibility, and it paved the way to have high quality in the type of the games, because their quality improved after this generalization in the software and hardware. And you can use different platforms, and it is not dedicated to one platform, and its cost benefit was lowered. And but we had this problem when the games started to be improved frequently and faster than before, then our computer resource starts to need to be upgraded more frequently than before. So it made a bottleneck, and for example, we needed to change the GPU of our computer when we wanted to play one game the next year, because our hardware is not enough, doesn't have enough capacity, computing capacity for this type of the game. So it makes bottlenecks. So the multiplayer scalability was as before. So we tried the cloud computing came to help the video gaming and improving this type of the application. So here I want to only mention three patents that they were the beginning and the start of the cloud gaming. And I wanted to only mention, and I tried to skip so fast. The first patent was about the remote rendering and streaming the game to the thin client, because we didn't need to have the more powerful computer, and we don't need to It is not depending on the hardware. And they started, it is the first patent, and then we had the other patent that it is the real-time game streaming, low latency input capture and encoding. And the other is about the content delivery network, CDN, and web-based game trial, because they try to make the video game service easier than before. When we use the cloud gaming, when we use the cloud computing for the video games, we use the data centers to host the platforms. In the host, we have the hardware like CPU, GPU, RAM, storage that already we have in our computer. And only in our case, in the client side, we need to have a zero or thin client only to receive the video frames and only to receive the input like joystick or controller input data, and use the display like TV and monitor to see and watch the frames. Yes, this is it makes easy to play with many devices. So we don't need to have the powerful hardware. We don't need to be limited to one software or operating system. So it was we don't care about the upgrades and the maintenance of the hardware, because all of this happened in the data centers and in the cloud. But one thing happened and one thing appeared that it is new, and it is the network requirement. Because when we use the cloud technology for the video games, we are talking about the internet, because yes, it paves the way to play with all devices, and we don't need to have the powerful hardware, and it is easy to connect. Only we need to have the internet. But we have this type of the challenge. It is the network challenge. Okay, the network naturally poses the latency to the video games, and in the multiplayer, we have the other requirement that it is important, because when two game players are playing together, they need to have equal quality of service. Because when one of them doesn't have the same quality of service, it can cause one of them loses because of this. I want to show that how important network is, because when we are using the cloud gaming, game as a service, network now is playing a critical role in this way. And the first one is latency for that caused by propagation, transmission, queuing, processing, and the other is the synchronization between two game players, the synchronization between uplink and downlink, and it is the new challenges in the network that we need to care about that. There are some commercial and open source cloud gaming platforms. The commercial one like NVIDIA GeForce, Xbox, PlayStation, Shadow PC, and Boosteriot. And in the open source cloud gaming platforms like Gaming Anywhere and Moonlight and Sunshine are open source, and we can install the cloud gaming server locally, and we can have the cloud gaming in our lab, for example. I want to show some facts about this that we need to know about the cloud gaming. First of this, that the user of the internet is growing. We have 5 billion, more than 5 billion people that are connected to the internet and using the internet. And the devices that are are owned by the people using the internet, or they have different types of the devices. As you can see, I wanted to show that game console is demanding yet, because they have this capability to be connected to the internet and use some data. And now we know that the console in the console, the network interface is one important part of this device. And as you can see that most of the devices are used with the internet users, or they have mobility. For example, mobile phone, a smartphone, laptop, or desktop computers, and a smart TV. These are the devices. And in the statistics, you can see that this year, in 2025, we will have 455 million people that using cloud gaming and playing on the internet. Based on the statistic, we can see that different devices are used to play the games, and it is the new one is the virtual reality headset or the VR glasses, as you can see here. And yes, it is coming to push the technology and cloud gaming. In the past, yes, we used the smartphone more than the other thing, but now we see that virtual reality is coming, and in the next years, in the coming years, we expect to have more than this device. And in this slide, I wanted to show that in the video games, we have the video streaming, and we have different video streaming traffic that, as you can see here, and all of them are delay sensitive, and they need to be handled in the client side. But in the video games, we have something that it is interactivity. It means that we need to be more sensitive to the delay, because when we lose this interactivity in the competitive situation, we can lose the game, or we can win the game, only because of this latency. So it is more important than, for example, video conference. Yes, video conference is important, and the other video streaming is important, but in the cloud gaming, we want to know that, yes, it is interactivity, that when two players are competing with each other, they need to have the equal quality of service, for example. If they don't have these, one of them can lose the game if they are not synchronized. As you can see in this slide, the multiplayers, online multiplayers are growing, as I mentioned. So it is pushing the internet to be able to have a better quality of service and to keep the interactivity better than before. So here I start to talk about the cloud gaming traffic, because now we found that we have the network added to the video gaming, and now we have the game as a service or cloud gaming services provided by different platforms like PlayStation, Microsoft, NVIDIA. They are providing this type of the application using the internet, and we can use this service with different devices. And now we know we can have a different device, and we can install the application, or we can use the browser, and we can play the game using different platforms. But when we have the network, we have the propagation delay, interface delay, and queuing delay. The most likely delay and latency is belonging to the queuing with more jitter, because the latency in the queuing latency is changing and varying more than the other one. So it is important for the cloud game. So as to have one global view of the cloud gaming, we have two components. One of them is human, that it is game player, that all the time is playing. And in the other side, we have one server that this server is receiving the comment and trying to react based on the comment and generate the required frames and stream the frame to the game player. And game player, again, watch the frames and react based on the controller and send the controller commands to the server. And this loop is continuing all the time. Always we have this continuing during the play time. This type of the action and reaction that we have in both sides, in game player and in the server side, it shows that we need to have the interactivity. We have interactivity, and we need to care about this type of the interactivity. And it shows that when we have the two flows or two traffic, one of them is in the uplink and the other is in the downlink, they need to be synchronized. We need to have the synchronization in the action and reaction that we have in the server and the human side. So it is very important. On the other side, we need to have this synchronization between two game players that they are playing across for example, different geographical places in the world. We have some bottlenecks in the network. So one of them is in the edge network, that the game player trying to connect to the internet. It is called the edge network that we can have bottleneck here, because we can have more guys working or connecting to the internet using this edge network, and they are using different application to generate the traffic, so they can be a bottleneck in the receiving and sending part. That here you can see in the C2 and C3, and in the WAN part we can have the C4 can be bottleneck that is connecting the data center to the network. So we need to care about these bottleneck, because it is possible to have less resource than the required traffic or request. First of all, we need to start with the metrics or measures that we have for the quality of experience in the cloud gaming, specifically for the cloud gaming. For the cloud gaming, we can have a form and fill the form with the game player, and we can use the ACR and mean opinion score to have this evaluation about the quality of experience. But it is possible, but it is not so easy to have this in the network management. Okay, we need to use the objective measures. So in the objective measures, we need to extract some features in the network side. We can extract in the network side, and we can configure in the network side. The measures that we have in the downlink, it is belonging to the video that we receive from the server, is video frame rate, the resolution of the frame that we received, and freezes. Freezes is the when you are playing, you may have the lag or the screen freeze and you cannot do anything, and it is one part of the quality of experience that it can happen. and the number of the freezes and the duration of the freezes are important in this case. And the downlink and uplink, it is related to the interactivity between the game player and the CG server. It is the response time including the all the time that all the latency we have, when we send the command and we expect to receive the frames, and exactly the time that we receive the influenced or corresponded frames, it is called the response time. And the other thing is the frame age. Frame age is the time that from the generated from the exactly the time that the frame rendered and generated in the server until the frame received in the client side. It is called frame age. And quality of service measures, it is so common, and we know about this, and we heard more about this in the past. So it is throughput, end-to-end latency, delay, and packet loss, and jitter, and queue sojourn time, the time that packet spending in the queue in the network device. We have different commercial platforms that I talk about them, and they are closed source. We don't have any access to the source of this stuff of the platform. Four famous platforms that we use, and it is common now. It is Google Studio, and NVIDIA GeForce, and Microsoft xCloud, and Sony PlayStation. In this research, they showed that when we have the packet loss, when we have the bandwidth limitation, when we have the latency and jitter, what happens to the network, the cloud gaming platforms network traffic, and what happens to the rate, what happens to the latency, and they evaluate the quality of service measures in the closed platforms that we have. And they showed here, you can see that when we, for example, we have inter-arrival time is going to be smaller, and the rate is increasing. We see that here, you can see that here it is negative. It shows that the size of the payload was reduced during the gameplay, okay? And it is good to know about the quality of service for different platforms. And we have the other research that they did in 2022. It is about the cloud gaming analysis of the Google Studio, and they generated some data set. We use these data sets. These data sets are for 3 different games, and they have different types of the, for example, encoding, resolution, as you can see here, and most of them, I can say that the closed platforms, all of them use the RTP in the system to send the video and audio. The other research that they did is the downlink and uplink patterns for different games. As you can see here, different games, not platform, different games from one platform generate different types of the downlink and uplink, and it is nice. It shows that we can identify even the game application. We can say, oh, this traffic is for this type of the game, this game. This can be, for example, this game, and it is very important. They for example, compare the RTP, for example, average packet size and average inter-packet time and load for different applications. Here for the Google Meet and the game of the TR game that here they have from the first game that they used, and they reported it is so valuable. Generally, it is important, and it is the other research that it was done. We see that different operating system is used in different platforms. It is important to know that we have two types of the traffic. One of them is the platform station, and the other is the gameplay station. What is important for us in the quality of experience? It is more likely to be in the gameplay station, because yes, platform session is important to set up the game, to start to set up and configure the game. It is important, but most of the time is belonging to the gameplay session, that the game player received the frames. So most of the frames are received in the gameplay session. It is very important. And the gameplay session is most of the time is UDP traffic, but platform session is TCP. And we need to have this loop to all the time to have to evaluate and have a feedback in the network to cover the quality of experience related to the cloud game. To evaluate, for example, for platforms with quality of experience and compare the quality of experience in different platforms, we need to, for example, play in the same condition in the network, and we run the four platforms together and watch like this to be able to compare them. It is difficult to do this because when we play the game, the network condition is changing, and as you can see, the scene and reaction of the server is changing all the time. Let me go on a little faster to show that when we have the glasses, as you can see here, we have the customized screen in the VR glasses, and we can move when we are playing, and we can invite our friends to play together in our home, as you can see here. And you can drink and you can do the thing that it is done based on the pass-through capability of the VR glasses, and it is making the way that we can have the AR over VR glasses, and it push the quality in different phase. So here I want to I categorize in three phases to show the research that has been done or is doing now to improve the quality of experience. As I mentioned, that IP and port is changing, so we need to have some techniques in the machine learning to identify, yes, this traffic is based on the patterns, this traffic is for these platforms, for example. And then we can have prioritization for this game in the queue and the other application. First of all, we had the work that they tried to have some constraints in the network, and they introduced the features like mean packet size and the average inter-arrival time and standard deviation and the total size and total number of the packets for classification of the cloud gaming. We did a research about this, and we add AR and cloud gaming together as a classes. We tried to identify AR from the cloud gaming, and we use the decision tree and random forest classification. We deploy this in Tofino to be able to support in the network in the network in the core our network, and it is new that we use the RTP features, real-time protocol features. We use the frame size and interframe interval for classification because the frame rate and the frame size in the AR and cloud gaming can be different, and when we add the digital object to the frame, we have different types of this, and so we had good and we had accuracy around the 94 for the random forest. And we did the other research that we implemented this in the TAPI as an access point in the edge system, and we tried to evaluate the quality of experience only for the frames and video frames quality. And we only changed the queue size. We don't change anything about this. We only change the queue size because we wanted to know about the buffering in the games. As I mentioned that we need to have the real-time traffic for the cloud gaming. So we collected the data set for the augmented reality and cloud gaming. We use the network, normal internet of the university, and we go to the Fastened University, and we collected the data set using the 5G because we wanted to know what is the effect of the 5G with the internet that we are using here on the cloud gaming traffic, and we collected this, and it is available in the GitHub that it's here. The other research that was done was focusing on comparing two techniques. One of them is the class-based queuing, and the other is the L4S1 that they compare in their work. But nowadays, with using the virtual reality and VR glasses, as you can see, we need to have different techniques. One of the techniques that is done in one of the research, and it is the adrenaline. It is very important. They try to use they try to propose the rendering quality. They change the quality of the rendering based on the network condition, but they try to be all the time be aware of the network condition. And it shows the frame rate, as you can see here, and the VMAP score that it shows when the network is the condition of the network is not good. We see that the quality is reducing, is decreasing, but the frame per second, a frame rate is increasing. It is a good research about this. And the other technique can be in the client side. It is interesting that it was published in SIGCOMP 2023, and they tried to predict the next frame based on the command in the client side. And they tried to reduce the interactivity latency. And because of this, they call this zero latency interactivity or zero latency 3D cloud gaming, because we know that when we have the 3D cloud gaming, we need to have a big space of the network. As you can see here, that 3GPP recently published this that for the downlink we need to have the 600 for the megabit per second, and for the uplink 100, and it shows that for the and cloud gaming is categorized in the immersive traffic, and it is called immersive gaming, as you can see here. Finally, I want to conclude that yes, latency is important, and all the research we are doing here, we try to reduce the latency of the cloud gaming in the network management, and we have different techniques for reduce the propagation, transmission, queuing, processing. For example, the techniques that we had in the in the client and server side, not in the network side. We use the we try to reduce the transmission delay. I wanted to say that we have the frame age. It is good parameters that we try to use these during the network to optimize this for the cloud gaming. It is important thing. And when we want to do research in this cloud gaming, we need to have access to the cloud gaming platform. But most of them are closed source, so it is challenging for the researcher. And so we need to have one emulator for the cloud gaming. But now what we have is not proper yet, because we need to have something that consider the interactivity of the cloud gaming. And it is very important for the researcher to do this. Okay, that's over. And if you, I hope not to make you tired. And if you have any question, I will be happy to be able to answer.
Thank you, Alireza. No, this topic don't turn our students tired. I'm pretty sure they loved it. They are gamers. I was going through their questions here, so if you can stop sharing your screen, I will show you some of the questions that they have put. As every seminar has this activity that they need to do before the seminar, right? So they have done some literature survey on relevant publications, and they have also elaborated some questions. Okay, I've gone through them. For the time that we have, I will pick just a few. And there is one that repeats a lot, and it's very common to machine learning. It's about the drift of the model. So at least 3 or 4 students, we have over 40 students, okay, regular in this class, which is great, and over 30 were watching live, which makes me also very happy. They ask about this issue. So the traffic classification relies heavily on machine learning. How do you ensure that these models remain accurate and responsive as the user behavior change, the network patterns may change, the games may evolve? This is a classical issue. What are your thoughts? What is
Exactly. This is very interesting question, because yes, one of the things that we have in the cloud gaming, as I showed, game by game, we have different pattern of the we have different pattern in the network traffic. So we need to be able to train the model frequently. So we had one work that it is called Postman, and we did this. We tried to, we have a model, and this model is working. Yes, it is going to be overfit, and the accuracy will be high. And after a while, we see that, oh, it is 100%. But when we have the other game, we will have problem. It is correct. So we need to have this training frequently, and we have this work that it is called Postman, but it was deployed in the SmartNIC, that it tried to improve the quality. We simulated this in the SmartNIC. I cannot hear you.
Sorry, my bad. Another good one here is about the evaluation of quality of experience, objective, subjective. You have touched a little bit beyond traditional surveys. I think this student means like a subjective quality of experience. uh, what are emerging techniques or metrics specific for cloud gaming or AR XR? And this is right on the spot on an open research challenge, right? What would you comment on this one?
Yes, it is very important to do this. We have different types of the quality of experience. I try to mention about the measures that we have. In the network side, we use the frame age that it is based on the RTP frames. We try to have this in the network, to have one profile about this. That yes, for example, the frame age is 2 milliseconds, 3 milliseconds. And then we try to improve it or keep the quality at the same time. But yes, we know that it is related to the hue. And one of the research that they did on the cloud gaming, they say that they have many players with the same condition, but they have different feeling. And yes, it is one thing that we can do in the network side. And we have two parameters, two measures we use in the network, and we try to make it automatic. One of them is the frame age, and the other is the frame rate. We try to have this in the network side and try to keep it as it was in the server.
Mhm. Nice. I'm uh, I'm glad to see here over YouTube one comment from Marcos Carvalho from the Federal University of Minas Gerais, and he's contributing to the last question. This is great. So one of the other techniques that they have been working is transfer learning to adjust the model and try to overcome this problem. So transfer learning based quality of experience estimation for different cloud gaming contexts, so that you start with a better model. But in any case, you still need to go after the drift and continuously retrain. Thanks, Marcos. Thanks for having you online and for your contribution.
Yeah, I think we need to yes, for this technique we use the transfer learning in the postMAC. That it is a system that we had. We train the model, and we have one model that it is trained with one platform. Okay, we run this in the SmartNIC, and then it starts to learn online. What does it mean? It is in a loop all the time. It trains, and it is because of the diverse traffic model in the cloud gaming. We use this time. It is called postmap. I try to share this in the.
Mhm. Great. Yeah, we maybe Marcus, we can take this further offline on collaborating on this topic. Last question, okay? It's 2 p.m. Uh, just keep some light. Emerging protocols, architectures to address extreme latency and stability requirements. Just be quick. Is there any advances that from the protocols and network architectures that go into this latency and stability?
Uh, uh, in our case, we use, as I mentioned, that we were using in the bottleneck. We tried to handle the bottleneck. So what we could do is we could try to extract the cloud gaming and XR traffic. Then we use the congestion control model. It is called L4S, that it is end-to-end congestion control mechanism. And so we try to improve this in our model. But I think, yes, we have, for example, I know about some protocols like Quick, RTP over Quick, and media over Quick, that they can be used in this case in the cloud gaming, and we can work on this.
Yeah.
Yes.
And from the network architecture, there is this concept of slicing to reserve resources, slicing also over the air, over 3GPP, 5G and beyond, and end-to-end until the cloud, until the edge cloud. So yes, there is a lot of things going on. And with that, Alireza, we need to be strict with our deadlines. Students have their commitments now at 2 p.m., class commitments. I thank you so much for being here today. Looking forward to keep collaborating. And all of you, stay tuned for the next seminar. Okay, see the schedule, watch our updates over LinkedIn. And thank you a lot. Have a good end of the week.
Thank you very much.
Bye-bye.
Bye-bye.